Basic Concepts of FTC, brought to you by RavenStorm Robotics number 18860. We are Rice RavenStorm number 18860, an FTC team. We are all 6th, 7th, and 8th graders from Rice Middle School. This year is our team's first attempt at FTC, and our veteran team being the Rice Raven Club. Here are the contents of the video. First Tech Challenge, otherwise known as FTC, is a robotics competition for students in grades 7 to 12 to compete head-to-head by designing, building, and programming a robot to compete in an alliance format against other teams. FTC is an event created by the organization first with the goal of getting the youth involved in STEM activities. They have various programs for multiple age groups. The one we will be discussing is FTC, which is for those in grades 7 to 12 with teams of up to 15 people. Every year there is a new FTC season, and with each season comes a new game. Each year's game is wildly different from the year prior. The team's goal is to create a robot for that season's game.
Gracious professionalism is part of the ethos of FIRST. It's a way of doing things that encourages high-quality work, emphasizes the value of others, and respects individuals in the community. With gracious professionalism, fierce competition and mutual gain are not separate notions, but rather combined into a better, more fun and exciting form. This applies to every FIRST challenge, league, and it's what makes FIRST events great.
An essential part of FTC is the engineering notebook, which includes things like design process, testing, research, production, planning, outreach, and much more. Teams record down their journey from the very beginning to the end. A team can advance to the next levels of competition through their robot scores or through awards. Because awards are mostly based on the notebook and aren't based on the matches, it helps new or less advanced teams have a fair shot at advancing. These 3 pages below are pages out of our own engineering notebook.
CAD stands for Computer Aided Design. This is software that is used to assist in the design process. It allows you to design something in a 3D space on the computer. In the world, this is used for industrial design, architectural design, and many other fields. In FTC, this is used to help design the robot, and it can be used to create custom parts which could then be 3D printed or milled by a CNC machine. CAD software helps the team plan out the robot design, but also note that CAD software is not necessary for a successful robot. Some teams may have their whole robot or only certain parts, and others may not at all. It does, however, help find design flaws and remove headaches in the design process. CAD is strongly recommended for all teams in FTC. TinkerCAD is a basic version of CAD. It is easy to use and a good starting point to learn CAD. What makes TinkerCAD so easy is the fact that all its parts and components of your design are already pre-built. This means that you only need to change dimensions and orientation. Sadly, this is its greatest problem, as TinkerCAD designs are pre-built and you can only go with what they have. But TinkerCAD is still a great place to start for a beginner.
Our team has used Fusion 360 and Autodesk Inventor in our season. However, depending on what computer hardware teams have or what the needs from the software are expected, they may or may not be for your team. In the description of the video, we have linked the Game Manual 0, which is a great resource for rookie teams, and it contains a lot of FTC information. On the Game Manual 0, under the robot design section, there is a CAD subsection. This section will detail the pros and cons of CAD softwares, so you can decide what's most effective for your team. If you are a beginner, we recommend on-chip CAD software. This software is cloud-based like TinkerCAD, meaning it can run in your browser. And there's a lot of resources available for the software that will make it easier for non-experienced people to learn.
The CAD designs that
that are made by your team will be what your robot is based off of. For building, you have building materials like Rev and Tetrix parts to make your main robot. The main part of your robot is the frame and control system, and the most important part of the robot is the frame, because it decides how effectively your robot can move around and complete tasks.
Programming is quite useful in robotics, especially FTC. What is programming? Programming is a set of steps of designing and building a computer program to accomplish a specific result or to perform a specific task. An easy way to think of it is a computerized algorithm. An IDE, or Integrated Development Environment, is a software where you can write and test code. Although there are many different programming languages and IDEs, most FTC teams use Java as their programming language and Android Studio or Onbot Java as their IDE, since they are the most common IDEs for FTC. Java is commonly used for robotics. As you might have known, computers can only understand ones and zeros, known as bytecode. Source code is the normal text or block code. So in order to convert source code to bytecode, a compiler is needed.
In FTC, teams use an expansion hub with an Android device, or a control hub with a built-in device. The hardware of the robot, like motors or servos, all connect to this hub. You can think of the hub as what allows the code in the phone and the hardware of the robot to communicate with each other. With blocks in Onbot Java, you connect directly to the hub that you are using. This allows for automatic updating, and code files are stored in the hub, meaning any compatible computer could connect and work on where it was last left off. Blocks, like the name suggests, uses block coding. This is good for new teams who don't have much coding experience. Onbot Java is a text-based coding interface and is better if you would like a bit more control. The final and most advanced form is using Android Studio. This uses the same SDK as Onbot Java, meaning writing the code is the same as in it. The difference between the two is that Android Studio is a much better IDE, and it allows for the use of custom code libraries and other more advanced softwares. However, the coder must connect to the hub or Android device. The benefits only come in handy with an experienced FTC and Java coder. This is why it's recommended only for experienced coders and teams.
Thank you for watching this video. If you like this video, please share it with your friends and family. And that concludes the video. We hope you learned something today and enjoyed the presentation. If you have any questions or comments, please put them in the comment section where it will be answered by us.